Have you ever been, like, in a car crash where a 3-second moment just felt like an absolute hour?
Oh, yeah, where it's just, like, terrifyingly slow.
Right. The glass shatters in literally slow motion, the sound gets all warped, and your brain just seems to record every single millisecond.
It's intense.
Or, I mean, on the flip side, have you ever been so deeply immersed in a project, just so totally lost in what you were doing, that a whole day vanished into thin air?
Oh, totally. You look up and it's suddenly pitch black outside.
Exactly. We all know that feeling.
Okay.
Subjective time is just incredibly slippery.
It really is.
Usually we just write that off as a quirk of human psychology, like, oh, it's just the brain misfiring under stress or, extreme focus.
Yeah, just a biological glitch.
Right. But today, we're tearing into this fascinating piece of science fiction. It's an excerpt known in our sources simply as Chapter 5.
And it is wild.
It really is. It takes a uniquely rigorous approach to real-world quantum mechanics.
Yeah, because it takes that everyday experience of time distorting and asks this terrifyingly plausible question. Like, what if that isn't just a trick of the mind?
Right.
What if it is a measurable physical law of the universe and we just hasn't figured out the math yet?
And that right there is the mission for today's deep dive. We're going to explore how this text uses a really gripping narrative to introduce a literal mathematical blueprint for exactly why our minds warp time.
It's a huge concept.
It is. So we'll be following a character named River as she uncovers a mystery that leads directly into the formulation of a brand new law of physics.
I love how it starts, too.
Yeah, okay, let's unpack this. The text frames this radical idea of mental time travel through, like, a classic mystery setup. River is given this mysterious, letter-bound book by someone called the philosopher.
Sounds very ominous.
Very. And she turns to a chapter titled The Physicist Who Vanished.
Which is just the perfect entry point. I mean, River reads the story of Dr. Felix Kline, who was this theoretical physicist who essentially decided that, writing abstract equations on a chalkboard just wasn't enough anymore.
He wanted more than theory.
Exactly.
Yeah.
He wanted to physically experience the quantum phenomena he was studying.
Which is dangerous.
Highly. And the hook of the chapter is incredibly stark. Dr. Kline was last seen at 3:42 p.m. on October 13th, just in his laboratory. And then he simply ceased to exist.
Just gone.
Poof, gone.
And the details of his work leading up to that moment, that's where the science gets really dense. Kline believed that time wasn't like a flowing river that only moves in one direction.
Right, which is how we all normally think of it.
Exactly. He called it a boundless ocean.
Oh, wow.
Yeah, his theory was that this ocean is entirely accessible, provided you could achieve the exact right state of consciousness and the right energetic field.
He talked a lot about standing waves of time, right?
He did. He described them as zones where the past, present, and future sort of converge into a single navigable point.
Which is crazy, but the physics behind a standing wave is actually grounded in real acoustics.
Oh, really?
Yeah, and wave mechanics. Like, if you think about a standard wave moving across an ocean, energy is traveling from point A to point B.
Makes sense.
But a standing wave occurs when two waves of the same frequency interfere with each other while traveling in opposite directions.
Okay, so it's like a guitar string.
Yes, perfect analogy.
When you pluck a guitar string, the vibration travels down the string, hits the bridge, and then bounces back.
Right.
And at the exact right frequency, those waves overlap perfectly. The string vibrates wildly in some spots, but there are points nodes, I think they're called, where the string appears perfectly still.
Even though there's a massive amount of energy flowing through it.
Exactly.
And that's the exact mechanism Kline was trying to apply to time.
It's mind-blowing.
It is. He believed time is composed of these interfering waves of quantum probability. So if he could find the node, the standing wave of time, he wouldn't perceive time as a linear sequence of events anymore.
He'd just see all of it.
Right. He would experience the whole spectrum of it simultaneously, perfectly still.
And to get there, his philosophy was, frankly, pretty radical. The text quotes him saying, "To step outside time, one must first realize one is never truly in it."
That is just such a fundamental challenge to how we perceive reality.
It really is.
Because we just assume we are embedded in the fabric of time. But Kline argues time is just a construct that human consciousness kind of passively drifts through.
Like we're just floating along.
Yeah, and if we shift our consciousness and apply the right external energy, we can just step out of the current.
Which brings us to the actual day he vanished. He apparently built this array of lasers, mirrors, and superconductors to create a, quote, time interference field.
Sounds expensive.
Very. And witnesses outside his lab reported hearing this hum that just kept growing louder, followed by a soundless flash of golden light.
Just soundless. That's creepy.
Right. And when they rushed in, the equipment was untouched. But Dr. Kline was gone.
No trace.
Zero.
Yes.
No heat signature, no scattered molecules, just a note on his desk that read, "I am here and I am everywhere."
So good. And his colleagues were totally divided on this. I mean, some naturally assumed he just vaporized himself.
I mean, that's what I would assume.
Right. But the text suggests something far stranger. It suggests he succeeded.
That he actually stepped out of time.
Exactly. That he stepped into a realm beyond time, rendering himself totally invisible to anyone still trapped in the linear flow.
Okay, so River is reading all of this, and she's captivated, obviously, but also entirely frustrated.
Yeah.
Because she's been conducting her own experiments with consciousness.
Right. So this hits close to home.
Yeah, these questions are physically weighing on her. So she closes her eyes just to process it all. And when she opens them, the environment around her has shifted.
Oh, this part is so cinematic.
It really is.
Yeah.
She's no longer in a room. She's suddenly sitting at her usual table in a local cafe. The atmosphere is thick, unnaturally quiet.
Almost heavy.
Yeah, heavy. And across the room, this figure named Mr. Kronos is quietly refilling cups. And then a tall, rumpled man with incredibly nervous energy approaches her table.
He's just darting his eyes everywhere, clearly looking for an escape route.
So paranoid.
Yeah, and he points at the leather-bound book. He tells her he's read it 3 times.
And River is just trying to be casual, like, oh, I read it to find new perspectives.
Right, but then the man makes his move. He spots Mr. Kronos watching them, his expression gets super dark, and he just grabs River's hand.
And he pulls her right out of the cafe and into absolute darkness.
The transition here is wild.
It really is. The darkness ripples like ink, and River sees these fractured reflections of the cafe, her own memories, people she loves. Seconds stretch out, hours fold into instants.
It's pure sensory overload.
Yeah. And when the shadows finally peel back, they are in a dimly lit room full of glowing monitors.
And the nervous man tells her they are in the gray zone.
Right.
He calls it the space between thoughts, between moments, and crucially, between the simulator's perception and hers.
Which is wild. River looks through a ripple in the room and sees Mr. Kronos out in the cafe, but he's frozen in place like a paused video.
Because, as the man explains, they are hidden from the simulator's eyes in this space.
Okay, I have to be honest here. This is where the text almost loses me.
Oh, really? How come?
Well, the simulator. Unplugging into a hidden room with computer monitors. I mean, are we just ripping off the Matrix here? Is the author actually arguing that River lives in a literal computer simulation and they've just, like, hacked the mainframe?
I get that. It's so easy to read it that way, and honestly, the text intentionally sets that trap.
Okay, so it is a trap.
Yeah, it's not a literal computer simulation. The simulation the man is referring to is actually your brain's baseline rendering of reality. Yeah. The text grounds the gray zone purely in human psychology and neurobiology. He points out that when people experience déjà vu, or, looping memories, or when time slows down during a car crash like we talked about.
They're brushing against the edges of this gray zone.
Exactly.
Okay, so it's about the gaps in our own perception.
Yes.
That makes more sense. Think about your morning commute.
Right.
You pull into your driveway and realize you have absolutely zero memory of the last 3 traffic lights.
Oh, I hate when that happens. It's so unsettling.
It is, but your brain was just on autopilot. It essentially skipped the conscious rendering process for those 10 minutes just to save energy.
That is the perfect real-world equivalent. The gray zone, at least in the logic of this universe, is the physiological and temporal space inside those skipped frames.
Inside the gaps.
Right. It's the micro-milliseconds between our conscious thoughts. Normally, the brain stitches moments together so seamlessly that we experience the illusion of continuous time.
Like a movie projector.
Exactly. But with enough emotional intensity or a shift in the quantum field, those gaps widen. You can literally slip into the seams of your own conscious rendering.
Wow. Which triggers a massive realization for River. The nervous energy, the deep knowledge of time, the desperation to pull her into the gaps.
She puts it all together.
She does. She realizes this rumpled man is Dr. Felix Kline.
The vanished physicist.
Yes. He didn't disintegrate in his lab. He slipped into the gray zone.
He didn't bring her here just to prove he survived.
Nope.
He brought her here to finish his life's work.
He needs her to formalize the theory. Because Kline explains that physical time travel, like actually moving a human body through physical space-time, requires immense mass.
Which is impossible for a person. I mean, generating the gravitational pull of a black hole, not going to happen.
Exactly. But then he introduces the core concept of the story, mental time travel, warping what he calls brain time.
I love that phrase, brain time.
It's great. And brain time requires a completely different kind of gravity.
He called it cognitive mass.
Cognitive mass.
Right.
And it is created by extreme emotional and attentional intensity.
And this is where River instantly shifts into a scientific mindset. She's not just passively listening anymore.
Yeah, she tells him that if they are going to formalize this, they actually have to measure it. She suggests using an EEG to track electrical activity and fMRI scans to track blood flow.
She wants to map exactly what happens in the brain when someone generates this cognitive mass.
And Kline pushes her on the specifics. He asks, which brain regions she expects to light up.
And River lists them based on actual, real-world neuroanatomy.
This is where the author's rigorous research really shines.
It's so impressive.
It is. She lists the thalamus, the prefrontal cortex, the hippocampus, the insula, and the claustrum. Let's break down the neuroscience here for the listener, because it's not just random biology jargon. Why those specific regions?
Well, the text links these regions to the 3 pillars of subjective time. So that's emotional intensity, conscious focus, and chronological ordering. So the thalamus is your brain's relay station. It dictates what sensory data you actually perceive in the first place.
Filtering out the noise.
Right. Then the prefrontal cortex handles your deep, sustained conscious focus.
Like when you're studying or solving a puzzle?
Exactly. And the hippocampus is the memory center. It's responsible for ordering events so you know what happened first, second, and third.
Okay, so that handles the chronological part. What about the insula?
The insula processes that deep, visceral emotional intensity, like the sheer panic of a car crash, or the profound flow state of painting for 6 hours.
Right.
But the real linchpin in all of this is the claustrum.
Yeah, the claustrum is fascinating. In real-world neuroscience, researchers like Francis Crick theorize that the claustrum is essentially the conductor of consciousness.
A great way to put it.
It's this thin, irregular sheet of neurons that connects to almost every other part of the cortex. It binds all these disparate signals together.
So the sight of the car, the sound of the glass, the panic in the insula, the focus in the prefrontal cortex.
Yes, it takes all of that and synchronizes them into a single, cohesive conscious experience.
So to put it all together, it's like your brain becomes a temporary black hole.
Exactly. In astrophysics, a black hole uses physical mass to create gravity so strong it warps physical space-time.
Right.
But here, when you experience intense trauma or hyperfocus, the insula, the hippocampus, and the prefrontal cortex fire so violently, and the claustrum binds them so tightly that your cognitive mass becomes incredibly dense.
It literally generates a gravitational pull.
Yes. It drags subjective time into its orbit, stretching a 3-second event into an hour.
You're hitting on the exact mechanism Kline and River are formalizing. It is a literal gravitational pull, but generated by the electromagnetic field of the mind.
It's brilliant.
And Kline is so impressed by her neuroanatomical breakdown that he summons the ultimate tool to finish the job. He just pulls this glowing, translucent panel out of thin air.
Which he calls the quantum slant.
Such a cool name. He hands her a humming stylus and basically challenges her to define this entire concept mathematically.
This is definitely the climax of the chapter. River is stepping up to bridge the gap between Einstein's physics and human consciousness.
No pressure, right.
Right. So Kline starts the equation. He writes down the standard formula for physical time dilation from special relativity. We know from real-world physics that physical velocity slows time.
Like the classic spaceship example, if you get in a spaceship and travel near the speed of light, time passes slower for you relative to someone just standing still on Earth.
Exactly. So Kline taps the board and asks River, what is the mental equivalent of physical velocity?
And River looks at the baseline physics and realizes that in the realm of consciousness, the equivalent of physical velocity is emotion and attention.
Emotion and attention? When your mind is accelerating through intense emotion and deep attention, subjective time stretches.
Yes.
When your mind is at rest or completely distracted, time contracts and just flies by.
Which brings River to the math. She takes the stylus and begins integrating real physical constants into the relativity equation to quantify this. And she starts with Planck's constant.
Using Planck's constant is such a stroke of brilliance by the author. In real physics, Planck's constant is fundamental to quantum mechanics.
It really is. It's the value that links the frequency of a photon to its quantum energy.
Right, the equation is E.A. Chef. Energy equals Planck's constant times frequency. But that's usually used for measuring light.
Yeah, so how does she bridge a quantum light measurement to human emotional energy?
Exactly, that's the leap.
Well, she does it by treating the brain's electromagnetic field as a quantum system. The brain operates on measurable frequencies, right? Alpha waves, beta waves, gamma waves.
Oh, right.
So River is applying Planck's constant to the frequency of neural oscillations in the claustrum and insula. She's basically proposing that emotional intensity isn't just a feeling, it has a quantifiable quantum energy yield.
That is so cool. And then she adds the gamma factor to the equation. Now, in standard relativity, the Lorentz factor, which is often represented by gamma, is used to calculate how much time or space distorts as you approach the speed of light. But here she repurposes it. What is gamma measuring in her new equation?
In River's formula, gamma measures the rate at which the brain's quantum state collapses.
Wait, quantum state collapse? Like, are we talking about Schrödinger's cat here? Where the act of observation forces reality to pick a state?
Essentially, yes. The theory of quantum decoherence suggests that quantum systems exist in a superposition of probabilities until they interact with their environment.
Or until they are consciously observed.
Right. And River is applying this to attention. When your brain is unfocused, your perception is in a superposition of scattered thoughts and sensory inputs. You aren't fully locking on to any one reality.
You're just kind of drifting.
Exactly.
But the moment you laser focus your attention onto something like a complex math problem or painting or a car suddenly swerving into your lane,
You force that quantum state to collapse into a singular, highly dense, experienced reality.
wow.
Yeah. The gamma factor in her math dictates that the faster and harder your attention forces that quantum collapse, the more time dilates.
And finally, she factors in the uncertainty of the breadth of attention, completing the whole integration of quantum mechanics into cognitive function.
It's quite the equation.
She stepped back, totally breathless, staring at the math on this glowing board. The scientific takeaway from her equation is just profound.
It really is.
Just as physical mass curves the fabric of space-time, the human mind curves subjective time. Greater emotion and deeper laser-focused attention physically stretch time out.
And conversely, scattered attention, or what she terms decoherence, causes time to compress. You literally lose the day.
And the thematic climax of this scene is beautiful. As she finishes writing, the text describes the shadows of the gray zone faintly rippling around them.
It's like the room knows.
Exactly. The hidden dimension they are standing in actually recognizes and reacts to the math she just formalized. Kline looks at her, thoroughly vindicated, and announces that she's just written the first law of quantum conscious time dilation.
If you step back and look at the magnitude of this idea, it just completely reframes human existence.
It really does.
In the universe of this story, human emotion isn't just some biological byproduct of evolution. It isn't just a chemical cocktail washing over your synapses to help you avoid a predator or, bond with your tribe.
Right.
Emotion is a literal quantum force. It is an energy capable of bending the fundamental architecture of reality.
It bridges the gap between the cold, hard physics of the universe and the warm, messy reality of being human. It gives mathematical weight to what it means to actually feel something deeply.
Beautifully said.
So let's summarize the journey we've taken in this deep dive. What started out as this gripping narrative about a vanished physicist and a hidden dimension called the gray zone evolved into a breathtaking exploration of neurobiology and physics.
Yeah, we moved from standing waves of time and the mysterious simulator of human perception straight into the claustrum, Planck's constant, and the mechanics of quantum decoherence.
And we arrived at the first law of quantum conscious time dilation.
Yeah.
The rigorous mathematical argument that cognitive mass, which is generated by our own emotion and focus, creates a gravitational pull on time itself.
For you listening right now, the implications of this are just incredible to think about.
Absolutely.
If this fiction holds a mirror up to our reality, it means your own focus is a personal time machine. When you deeply engage with a moment, when you are fiercely present and emotionally invested in the people or the work in front of you, you are literally stretching your own lifespan from a subjective standpoint.
You are making your life longer by simply paying attention to it.
Exactly. But the math cuts both ways.
Right.
When we lose our focus, when our attention scatters into a dozen different directions, we are experiencing decoherence. We are collapsing time.
Which brings me to a final thought I want to leave you with today. Just something to mull over the next time you look at the clock and wonder where the day went. If cognitive mass and deep, sustained focus stretch time out, and if scattered attention and decoherence cause time to collapse. What exactly is happening to our subjective lifespans when we spend 3 hours mindlessly scrolling through short-form videos? When we swipe past 50 different contexts, emotions, and faces in the span of a single minute, are we simply decohering our attention? And in the process, are we literally fast-forwarding through our own lives?
That is a terrifying thought.
Thank you for joining us in the Gray Zone today. We'll be waiting for you in the next deep dive.